Hello, good morning students. Today we are going to discuss next unit 3, Relational Data Model. In this video, we have to discuss introduction, EF Court's rules and explanation about Relational Data Model. Okay, let's start. Relational Data Model Introduction. Okay. In 1970s, EF Court of IBM the relational data model was introduced in 1970 by E.F. Codd of IBM and it's in his landmark paper. That paper is known as a relational model of data for large shared data banks. Okay. Uh, The relational data model represented a major breakthrough for both designers and users. It provides a conceptual simplicity. Actually, in 1970s, E.F. Codd's work was considered ingenious and impractical due to lack of computers' power to implement relational model. Okay, after that, computer efficiency was increased. As an impact of Codd's paper, System R project was developed during the late 1970s by IBM San Jose Research Laboratory in California. This project was developed to prove that the relational data model was implementable. Okay. Actually, the outcome of System R project was development of a structured query language SQL, which is the standard language for a relational database management system. In relational data model, the relational data model was implemented through RDBMS, Relational Database Management System. Some of the relational database management system products are Oracle's SQL, DB2, Microsoft SQL Server, MySQL, like that. Okay. And one of the important advantage of a relational database management system is its ability to hide the complexities of the relational model from the user. That means it provides a flexible environment to the end users and designers. Okay, and the RTBMS manages all of the physical details while the user sees the relational database as collection of tables in which data are stored. Okay. Okay. So next, E.F. Court's rules. In 1985, to evaluating a relational database system, Dr. E.F. Court published a list of standard rules. Okay, those rules became a standard way of evaluating a relational database system. So, what was his concern? To publish all those list of rules to evaluating relational database system. Dr. E.F. Codd published these rules. Actually, what his concern was that many vendors were marketing products as relational, even though those products did not meet minimum relational standards. Okay, that's why in order to evaluating relational database system, he has published rules, some of the rules. Okay, those rules was known as EF Codd rules. After publishing the original article, the Codd states that there was no system that will satisfy every rule. But these rules represents relational model ideal and remain a goal for relational database designers. Okay, that means when you are going to implement or when you are going to design a relational model, you must follow the rules which are guided by the EF code. Okay, then only that relational data model meet all the requirements of the relational RDBMS. Okay, coming to the rules. The first rule is known as the information rule. What is the information rule? All the information in the relational databases must be logically represented as column values in rows within the tables. That means the data will be represented in the form of table. Table is nothing but intersection of rows and columns. And second rule is guaranteed access rule. As per this rule, every value in the table is guaranteed to be accessible through a combination of table name, primary key value and column name. Every data element should be unambiguously accessible. Okay, that means whatever data you maintained in the table, every value in the column should be guaranteed to be accessible. Okay, through a combination of table name, primary key value and column name. And third one, systematic treatments of null values. Okay, what are the nulls? Actually, nulls are distinct from empty characters, strings or string of blank characters, and distinct from zero and any other number. Okay, actually, what are the nulls? Null means if there is any not applicable value in that column, just you leave it as a blank. Okay, it's a empty. That value is called as nulls. Actually, those nulls are fully supported in the relational DBMS for representing missing information or inapplicable information in a systematic way independent of data type. Okay, why? Because when you are going to maintain the data in the tables, some of the columns may be not applicable in that particular situation. Okay, some of the data may be missing. Okay, so in that situation, we have to represent those missing information or inapplicable information with the null values. So null values are fully supported in the RDBMS. Okay, this is the third rule. Coming to the fourth rule, view updating rule. What is view? Actually, view is a virtual table based on the result set of an SQL statement. Okay, it's not a original table, but the virtual table constructed based on the result set of an SQL statement. Okay, and any view that is theoretically updatable must be updatable through the system. That means all the records in the file must be able to added, deleted or updated with singular commands. Okay, like a normal table, in view also we can add records, delete records, update records with the singular commands. That is view updating rule. Okay, coming to high level insert, update and delete. Okay, the database must support set level inserts, updates and deletes. What are the meaning of set level inserts, updates and deletes? Means you can insert multiple records at a time. You can update multiple records at a time. You can delete multiple records at a time with a singular command. Those inserts and those updates and those deletes are called as high level. Okay, so those set level inserts, updates and deletes operations should be supported by the RDBMS database. Okay, coming to the physical data independence. Physical data independence. What is physical data independence? Okay, that means application programs and ad hoc query facilities are logically unaffected when physical access methods or storage structures are changed. That means when you are using a new storage device like hard disk or magnetic tape, modifying the file organization technique in the database or switching to the another data structures, or changing access methods. The application programs, already existing application programs and ad hoc facilities are not are logically unaffected. Okay, that is called as physical data independence. Coming to next rule, dynamic online catalog based on the relational model. Already we know that. What we know that in database, along with the data, we are going to maintain metadata. Okay, that what is metadata? Metadata is nothing but data about data, is known as metadata, and data dictionary also. That metadata also must be stored and managed as a ordinary data. That means in tables within the database. Okay, the main motto is such metadata must be available to the authorized users using standard database relational language. Okay, that means the metadata means the database descriptions, the data about the data should be accessible to the users. And next, comprehensive data sublanguage rule. The next rule is, what is this rule? The relational database supports many languages. Okay, that means it must support well-defined declarative language with support for data definition, view definition, and data manipulation, integrity constraints, authorization, and transaction management. All should be supported in that well-defined declarative language. Okay. Okay, that type of languages should be supported in the relational databases. Okay, that means in DBMS, it provides a declarative language. What is the declarative language? In declarative language, you need to specify what must be done. No need to specify how it is to be done. That means no need to write a lines of codes. Okay. So within the query format, you can specify what do you want. That's all. And it provides a declarative language with support of data definition, DDL languages, TML languages, commands. DDL is nothing but used to define the structure of databases, database objects like tables, views, indexes like that. And data manipulation means perform operations on the data within the databases like insert the data, update the data, modify the data. And coming to integrity constraints. So integrity constraints are used to ensure correctness of databases. Okay, so integrity constraints constraints nothing but rules and regulations we placed on the data in the database tables to ensure correctness of data. Okay, and authorization and transaction management all should be supported in the languages, those languages should be supported or should be available in the relational databases. Okay, and coming to logical data independence. Already we discussed physical data independence. Here is the logical data independence. What is logical data independence? Logical data independence means when you add or modify, delete a new attribute, okay, or merging two records into one, or breaking existing records into one or more records. So whatever changes you can do, the application programs and ad hoc query facilities are logically unaffected. Okay, that means when you are made any changes to the table structures, that means changing the order of columns or inserting columns, the application programs and ad hoc query facilities are logically unaffected. Okay, you need not to modify those application programs and ad hoc query facilities. That type of independence is called as logical data independence. And coming to integrity independence. Okay, what is integrity independence? Integrity independence means all the integrity constraints or rules must be definable in the relational language and stored in the system catalog. System catalog means metadata or data dictionary, not at the application level. Okay, so when you define some constraints along with the table definition, all those should be stored within the metadata, okay, not in the application level. That's very very important. This is known as integrity independence. And next one is distribution independence. What is distribution independence? A relational database management system always has distribution independency. Why? Because the distribution independency means user should not have to aware of whether the database is distributed or not. Okay. So why? Because no need to know about whether the database is distributed or centralized. Okay. The database design should allow for distribution of data over over several computer sites. Actually, the relational databases are distributed among several sites, but the user need not to know about whether the database is distributed or not. He can able to access the data as a single database. Okay. Coming to non-subversion rule. Okay. So if a relational system has a low level means a single record at a time language. That low level cannot use it to bypass the integrity rules and constraints expressed in the higher level relational language. Okay, that means multiple records at a time. That means low level commands, that means that affect a single record at a time commands, those cannot bypass the integrity rules and constraints expressed in the higher level relational language commands. That means those affects the multiple records at a time. Okay. And coming to last one, rule 0. So all the preceding rules are based on the notation that in order to for a database to be considered relations, it must use its relational facilities exclusively to manage the database. Okay. So all the rules indicates that the database to be considered as relational database. Okay, so when you follow all these, when your relational database follows all these rules, it must use its relational facilities exclusively to manage the database well. Okay. Coming to relational data model. Relational data model was introduced by E.F. Codd in 1970s. Actually, it's developed based on some mathematical concepts. Those mathematical concepts are predicate logic and set theory. Okay. So what is predicate logic? Predicate logic used extensively in mathematics, which provides a framework in which the assertions, that means the statements, can be verified as either true or false. And coming to set theory used in mathematical science, which deals with sets, a group of things, and used as a basis for data manipulation in the relational model. Okay. So actually these are the backbone to the development of relational model. Purely the relational model was based on the mathematical concept. Those concepts are predicate logic and set theory. Okay. And in this relational data model, all the data we used to maintain in the form of collection of tables. Okay. Mainly this model was built on mathematical concepts. And here in relational data model, the data and relationships are represented by the collection of interrelated tables or relations. Okay. That means the data was logically expressed in the form of tables or relations. What is table? Table is nothing but intersection of row and column, and it's a two-dimensional structure which consists of rows and columns. Okay. And each relation or table has a name and having some number of columns. Okay. And this relational data model is a combination of three components such as structural, integrity and manipulative parts. Okay, so coming to structural part. What is the structural part? This structural part defines the database is a collection of tables or relations. Okay, so first of all we are going to define the structure of the table. What is the table name? What are the columns we are going to store in that table? What type of data we are going to store in each column? Okay, that comes under structural part. Okay, and coming to integrity part, the database integrity is maintained in the relational model using primary key and foreign keys. Okay, so to maintain the correctness of data and consistency of data, and also maintain the relationship between among the tables, we used the concept of primary keys and foreign keys. Okay, actually with the help of these keys, database integrity is maintained here. And coming to the manipulative part. Manipulative part means how we are going to perform data manipulations on the data in the tables or relations. Okay, for that we are using the relational algebra and relational calculus tools. These are the tools used to manipulate in the database. Okay, and thus the relational data model has a strong mathematical background, and some of the relational database management systems are DB2, Informix Dynamic Server, IBM, Rackle, RDB, Rackle, SQL Server, and Access Microsoft, like that. Okay, and what are the relational data model concepts? So how we are going to store data in the relation or in the table? Okay, so first of all we are going to know about some terminologies. The first, attribute. Okay, each column in the table is known as attributes. Okay, attributes are the properties which defines a relation. Attribute is a characteristic of a table. Okay, and attribute which is used to define and store the data in the table or relation. Example, roll number, name, address, other number, phone number, like that. Okay, and coming to tables. So in this relational data model, the relations are also known as tables. Okay, and data model, those are known as entities. Okay, every table has two properties, rows and column. Table is nothing but a two-dimensional structure which is composed of row and column. Okay, here the row represents records and column represents attributes. Okay, coming to tuple. Tuple is nothing but a single row of a table is called as or a single record in the table is known as tuple. Coming to relational schema. Relation schema. So relation schema is nothing, represents the name of the relation with its attributes. Okay, for example, if you have a student table with the student roll number, student name, student marks, like that, then you are writing, the first of all you have to write the relation name. What is the relation name here? Student, and you can write those attributes after that table name. Student name, student number, student name, address, marks, phone number, like that. Okay, that schema is nothing but relational schema. Okay, and coming to degree. What is degree? Degree means the total number of attributes in the relation or in the table are called as degree of the relation. What is cardinality? Cardinality means the total number of rows present in the table. Okay, and coming to relational instance. What is instance? Relational instance is a finite set of tuples in the DBMS system. Okay, so that means all the records, all the tuples, all the records, all the rows, all the records are known as relation instance. Okay, relation instances never have duplicate tuples. So okay, those records or those rows never to be duplicated. Okay, that means every relation contains a finite set of tuples which does not contain any duplicate row or record. Okay, and coming to relation key, every row has one or two or multiple attributes, which is called a relation key, which is used to establish a relation among tables. And coming to attribute domain, every attribute has a some predefined values and scope, which is known as the attribute domain. Okay, attribute domain means it contains a range of values. For example, when you have a GPA column, okay, then when you have a GPA column in your student table, just the minimum value is 0 and maximum value is 0, 0.0 and minimum maximum value is 10.00, like that. Okay, when you have a max column for individual subject, then you need to enter the minimum value from 0 to maximum value 100 or 75, like that. So every domain, every attribute has a range of values from minimum to maximum value. That is known as attribute domain. And coming to the characteristics of a relation or table, okay, how we are going to represent a relation or a table. What is table? Table is a two-dimensional structure which is composed of rows and columns. Okay. Every table's row means it's a known as tuple also, represents a single entity occurrence within the entity set. Already we know that this terminology in ER model. Okay, and each table column represents an attribute and has a distinct name. Every column has a distinct name. Okay, and each row and column intersection represents a single data value also, data value only. And coming to next, all values in the column must conform to the same data format. Okay, that means in one column we are going to store numbers, then all values must be the numbers format. Okay, when you are storing a character format data in one column, all column values should have a character format, like that. Okay, and each column has a specific range of values known as attribute domain. Okay, and the order of rows and columns is immaterial to the DBMS. Okay, the order of rows and columns. And each must have an attribute, each table must have an attribute or combination of attributes that uniquely identifies each row. Okay, every table should have a every table should have a key. That key is known as primary key, that is composed of one attribute or combination of attributes that are used to identify each and every row uniquely. Okay, so if a table satisfies all these characteristics, then only it is said to be a relation. Just see this diagram, then you can understand. First, just see this terminology: the user and model and programmer. Okay, user, row, tuple, record is the same. Column, attribute, field, table, relation, and file. Okay, just the terminology is synonyms for row, for column, and for table. And just see this diagram, then you can understand what are the table characteristics. Okay, table is composed of rows and columns. Okay, and every table, some tuples, some attributes, and each attribute has a distinct name: SID, SName, SH, S class, and S section. Those are the distinct names. Okay, and each record is called as an entity instance. Okay, and each intersection of row and column represents a single value. Just you observe, and every cell it contains only a single value. Multiple values are not allowed in this table format. Okay, and each table should have a primary key to identify each and every record uniquely. Here we are taken the attribute of SID, student identification. Okay, just observe the identification values. Okay, those are 1101, 1102, 1103, 1104, 1105. This attribute values are unique. That means no duplicate values and no not null values also. No null values also. Okay, that's why by using the SID column we used to identify each and every record. Okay. So this is the table which satisfies the table properties. Okay. And the degree of relation means the number of columns in the relation are 5. And cardinality means the number of rows 1, 2, 3, 4, 5. Okay. Here this relation or table contains 5 rows and 5 columns. Here the 5 columns, here the 5 rows. Okay. This is a table which is known as relation also. These are the records are known as tuples and columns are known as attributes. Advantages of using relational model. What are the advantages? Simplicity. First one, simplicity. Okay, when compared to the hierarchical and network model, it provides a major breakthrough for both designers and users. It provides a simplified and flexible environment to the end users and designers. So it provides simplicity. Okay. And coming to structural independency. Structural independency means structural independency. That means if you change the structure of the table, you need not to change the application programs. The relational data model is only concerned with the data, not with the structure. That means no need to know about the physical storage details. Just you concentrate on how the data can be viewed. Okay, just this property can improve the performance of the model. And next one, easy to use. Why? Because in relational data model, the data will be logically represented in the form of tables consisting of rows and columns. Okay. So when you represent the data in the form of tables and columns, it's quite natural to understand very easily. Okay. And query capability. Query capability means in relational data model, it provides high level query languages like SQL. SQL is a declarative language. Okay, no need to write a codes of lines. Just by asking a query or question, you can retrieve whatever data you want. Okay, so it's a query capability. Next one, data independence. So data independence means if you make any changes to the existing data, no need to change the application programs also. Okay. Coming to scalable. Scalable means regarding a number of records, rows or number of fields. A database should be enlarged to enhance its usability. Okay. So that means bulk amount of data, large, huge amount of data to be supported in the relational data model, data models databases. Data models databases. Okay. Okay. So coming to frequently asked questions, what are the EF code rules? Explain. This is for 5 marks question. Okay. This is for this is for essay question. This is very important question. And next one is what is relational model and explain. Then you can write all the introduction and the concepts also. And third one, explain relation or table characteristics. Okay. This is for 5 marks question. It's very important question. Okay. So students, listen carefully and write the running notes. If you have any doubts, just contact me and clarify your doubts. Thank you.